Right under the noses of 8 million Americans, a geological bomb is brewing that everyone somehow ignores. We're not talking about the San Andreas Fault, not about the Cascadia subduction zone, and certainly not about some exotic supervolcanoes. The problem is located 80 kilometers from the city of Seattle, rises 4,500 meters, and looks like a perfect mountain from a gift postcard. This beauty is called Mount Rainier, and it just showed signs of life in a way that geologists haven't seen for decades. From July 8 to 10, 2025, more than 300 earthquakes occurred under this stratovolcano in 72 hours. But here's what really chills the blood. This volcano will frighten people not only with lava or ash, it has a much more treacherous weapon. 25 glaciers on its slopes, which, when in contact with magma, turn into deadly flows with temperatures in the hundreds of degrees and the speed of a freight train. Most terrifying is that thousands of Americans live directly on ancient deposits of such flows, essentially on a graveyard of previous inhabitants. What is happening underground in this area? What new data have scientists found? And what awaits America after this volcano's awakening? Millions of people live in the shadow of a giant monster that can wake up at any moment and wipe entire cities off the face of the earth in a matter of minutes. This is the new reality of Washington State, where one of America's most deadly mountains rises. A funny geographical confusion occurs every time Washington and seismic threats are discussed. People think about the US Capitol in Washington, D.C. with its political battles and government buildings. But the real hotspot is located 4,000 kilometers to the west in Washington State, which ironically turned out to be one of the most seismically dangerous regions of North America. This state is located at the very epicenter of tectonic chaos. Several geological monsters converge here at once. The Cascadia subduction zone, where the Juan de Fuca oceanic plate dives under the North American plate. The Cascade volcanic belt with its slumbering giants, and an entire network of active faults permeating the region like cracks in broken glass. Earthquake statistics in the state look frightening. From 1,872 to 2024, more than 400 significant underground tremors occurred here. The most destructive of recorded earthquakes was the 2001 Nisqually earthquake with a magnitude of 6.8. The epicenter was located 52 kilometers beneath the surface near Olympia, the state capital. Tremors were felt from Canada to Oregon, and in Seattle, part of the historic Pioneer Square district collapsed. But earthquakes are only the tip of the iceberg. The Cascade Range, stretching through the entire state from north to south, represents a real collection of volcanic time bombs. Besides the already mentioned Rainier, here is Mount Baker at 3,000, 288 Menor High Glacier Peak at 3,000, 213 Menor Mount Adams at 3,000, 743 m, and of course the sadly famous Mount St. Helens. Mount Rainier is not just a picturesque snow-covered peak that tourists love to photograph. It is an active stratovolcano capable of turning prosperous suburbs into lifeless wasteland overnight. The paradox is that precisely because of its deceptively calm appearance, Rainier long remained in the shadow of its noisier neighbor Mount St. Helens volcano, which spectacularly exploded in 1980. While all attention was riveted to smoking craters and lava flows, the real threat silently accumulated strength under a layer of ice and snow. More than 25 glaciers cover Rainier's slopes. This is more ice than on all other volcanoes of the Cascade Mountains combined, and it is precisely this ice that makes the volcano so deadly. The fact is that Rainier's main danger lies not in hot lava or ash clouds. Its main danger is volcanic mud flows which form when hot magma contacts glaciers. These flows have the consistency of liquid concrete temperatures in the hundreds of degrees and can rush at enormous speeds, sweeping away houses, bridges, and entire neighborhoods on their path. But here's what's truly shocking. About 150,000 Americans live directly on ancient deposits of such mudflows. The cities of Enumclaw, Ording, Kent, Auburn. They are all built on what geologists grimly call a mudflow graveyard. And now, in summer 2025, this sleeping giant is showing signs of awakening. From July 8 to 10, more than 300 earthquakes occurred under Mount Rainier volcano. This is the most powerful seismic activity in the last 16 years. Tremors followed one after another with frightening regularity, sometimes several per minute. The U.S. Geological Survey recorded that epicenters were located at depths from 1 to 6 kilometers directly under the volcano's summit. The strongest earthquake reached a magnitude of several points. To understand how serious recent events are, it's worth comparing them with previous activity surges. In 2009, 120 underground tremors were recorded under Rainier, which was then considered a significant event. The current series exceeded this figure almost threefold, with more than 350 earthquakes in 3 days. For comparison, usually only 9 earthquakes occur under this volcano per month. But there is one feature that makes Rainier especially treacherous. Unlike classic volcanic eruptions with warning signs, gas emissions, temperature increases, surface swelling flows, and collapses can occur suddenly. A local earthquake is enough to trigger a catastrophic process. Temperature sensors will show normal readings. There will be no gas emissions, and in half an hour, a deadly wave of mud will rush through river valleys. This is exactly why scientists installed a special mud flow detection system, a network of seismometers and sensors along all major rivers flowing from the volcano. This system can automatically identify characteristic vibrations of a mud flow and instantly activate sirens in populated areas. Theoretically, residents will have 30-40 minutes for evacuation. Theoretically, because in practice no one knows how locals will behave hearing siren wails on an ordinary weekday. In March, 2024 state authorities conducted the largest mudflow threat evacuation drill in history. More than 45,000 school children participated. Children were taught to immediately leave buildings and run to the nearest high ground upon alarm signal. It looks like a scene from a Hollywood movie, but for Valley residents this is harsh reality. What particularly worries volcanologists in the current situation is the character of seismic activity. Earthquakes concentrate at relatively shallow depth and have specific characteristics indicating fluid movement in the mountain's depths. Hot water and gases under pressure circulate through rock cracks, gradually weakening the volcano's structure. This process is called hydrothermal alteration, and it often precedes catastrophic slope collapses. History remembers several large-scale catastrophes connected with Rainier collapses, and each of them serves as a grim warning about what can happen again. A very ominous event occurred 500 years ago. The Electron mudflow got its name from the village of Electron, where its deposits were first scientifically studied. Without any eruption, simply as a result of western slope collapse, a flow formed that rushed through the Puyallup River Valley for more than 50 kilometers. Flow speed reached 70 kilometers, and mud mass thickness reached 20 m. Even earlier, about 5,000 years ago, a catastrophe of such scale occurred that the mudflow reached the Pacific Ocean itself, changing the state's coastline. Rainier's mudflows possess features that make them even more deadly. Unlike ordinary floods, which can be survived by climbing onto a house roof, mudflows have density twice that of water. They carry huge boulders, tree trunks, and building debris like toys. Flow temperature can reach 80 degrees Celsius, enough to cause severe burns. Modern computer models show terrifying scenarios. If that mudflow repeats, more than 100,000 people will be under threat. The flow will reach Orting City in 30 minutes, Puyallup in an hour, and Tacoma suburbs in an hour and a half. Evacuating such a number of people in such a short time seems an almost impossible task, especially considering that main highways run precisely through river valleys, that is, along mudflow paths. But the most absurd thing in this situation is the economic factor. Despite obvious threat, cities near the volcano continue to grow. Real estate prices here are among the lowest in the region, precisely because of volcanic risk, which attracts buyers. A vicious circle emerges. Danger lowers prices. Low prices attract more residents, which increases the potential number of victims of future catastrophe. Insurance companies perfectly understand the risks. Standard homeowner policies don't cover damage from volcanic phenomena, including collapses. Separate insurance against volcanic risks costs astronomically and has many limitations. In fact, most residents of the risk zone are financially unprotected from catastrophe that can occur at any moment. The economy of all Washington state significantly depends on areas under threat. Key transportation arteries connecting Seattle with southern parts of the state pass through Puyallup Valley. The port of Tacoma, one of the largest on the U.S. West Coast, is also in the potential flood zone. The Federal Emergency Management Agency estimates potential damage from a major mudflow at $40–80 billion. This is comparable to damage from Hurricane Katrina, but with one important difference. Hurricanes can be tracked and forecast for days and weeks, while flow descents can arise practically without warning. Therefore, state authorities are in a difficult position. On one hand, complete evacuation of dangerous areas is economically unrealistic and politically unfeasible. On the other hand, each year of delay increases the number of potential victims. Recent seismic activity under Rainier forces scientists to reconsider their forecasts. David Tucker, one of the leading specialists in Cascade Range volcanology, notes an alarming trend. The frequency of seismic swarms under the volcano is increasing. If previously similar events occurred once every few years, now activity is observed practically annually. This may indicate fundamental changes in the volcano's magmatic system. Climate changes add another unpredictable factor to this equation. Climate warming accelerates glacier melting on Rainier's slopes. Over the last 50 years, ice volume on the volcano decreased by 20%. Paradoxically, this simultaneously reduces and increases risks. On one hand, less ice means smaller volume of potential deadly flows. On the other hand, retreating glaciers leave behind unstable piles of debris material that can collapse from the slightest tremor. Comparison with other volcanic catastrophes doesn't add optimism. In 1985, a relatively small eruption of Nevado del Ruiz volcano in Colombia caused mudflows that completely destroyed the city of Armero with a population of 25,000 people. The eruption magnitude was only 3 on the Volcanic Explosivity Index. This is considered a weak event, but hot lava melted glaciers on the summit and formed mudflows overcame 60 kilometers in 3 hours. Rainier is potentially capable of a much more large-scale catastrophe. Ice volume on its slopes is dozens of times greater than was in Colombia. There are also significantly more populated areas in the risk zone. In the most unfavorable scenario, southern Seattle areas with a population of more than 500,000 people may be under threat. Volcanologists don't like to give concrete forecasts, but statistics are inexorable. Based on geological history, Rainier produces flows on average every 500–600 years. The last large flow was 500 years ago. This doesn't mean catastrophe will occur immediately. Volcanoes don't work on schedule, but this means we live in a period of increased risk. Modern technologies give hope for early threat detection, but they also show the limits of our capabilities. Nature can present a surprise that isn't provided for by any algorithm. The tragic irony of the situation is that Rainier's beauty and accessibility is precisely what makes it so dangerous. If this were some remote mountain in an uninhabited area, the threat would be purely academic. But proximity to large cities, developed infrastructure, millions of tourists annually, all this turns a sleeping volcano into a potential humanitarian catastrophe of enormous scale. Perhaps recent earthquakes are just another false start, as has already happened many times over recent decades. Perhaps Rainier will sleep for hundreds more years, but perhaps we are now observing the first symptoms of awakening of one of the planet's most dangerous volcanoes. In geological timescales, the difference between soon and someday may be only a few moments, and one of these days the moments may run out. If it was interesting, give it a like and subscribe to the channel.